an upflow anaerobic sludge blanket technology. This is also known as UASB reactor. So this is basically a form of anaerobic digester. This is mainly used for wastewater treatment. So this is mainly done for high strength wastewaters. Okay. So normally this is more adequate when we are using industrial waste, etc. This method was developed by a Netherlands scientist named Getse Lettinga in the year 1979. So this USB is also known as three-phase separator because this enables the separation of solid, gas and water even in high turbulence conditions. So this actually allows for very cheap compact designs. So this figure shows a model of USB reactors. At the bottom, there will be an inlet zone. Then there is a sludge blanket zone. Then you can see the rising biogas, and the biogas is collected in these gas collection domes, and the free water is uh, collected and taken out as treated effluent, and the biogas is taken out at the top, and the solids are deposited or allowed to deposit in the tank itself. So that is how this sludge blanket is generated. So this is basically the working of a UASB reactor. So the various zones and components of a UASB reactor. So it basically consists of a inlet zone. So inlet zone is mainly, you can see the cursor. So your inlet zone, through this inlet zone, the wastewater or our water to be treatment is taken into the reactor. Okay. So there will be some perforations to allow the uniform distribution of influent into the system. And there is a sludge blanket or a reaction zone where the inlet or the influent is reacted with the sludge that is there, which contains anaerobic bacteria. So these anaerobic bacteria will actually helps to degrade the organic matter that is present in the influent, and biogas is formed. So these biogas, as they rise up, they will get collected into the gas collection dome, and the clear water is or the water is taken through this sloped surface, and it is taken out using this outlet, and the solid particles that is present or the decomposed solid particles that is present in the water is allowed to settle, and this it contains a bacteria. So these anaerobic bacteria will actually be helping with the remaining digestion process. Okay. So it will so basically it has an inlet zone through using which the influent is entering into the system. That's a sludge blanket zone, which allow where the biochemical action or the decomposition takes place. Then there is a settling zone at the bottom where the solids are allowed to settle, and there is a gas liquid separator. So here the gas is taken to the biogas chamber, liquid is taken out through this effluent, solids are allowed to deposit. Okay, so these are the various zones that are present. So how does this work? Sludge blanket that you see actually comprises of various microbial granules. That is basically those are agglomerates or groups of microorganisms. And because it has quite weight, it doesn't flow up. So from the inlet, the water is flowing up constantly. And since they have some weight, they will actually retain here. They will not settle, and they will not, since they have weight, they will not flow upwards. The microorganisms that is present in this sludge blanket will actually help to degrade the organic compounds that is present in the water. So as a result of this decomposition, biogas is released. That is a mixture of methane and carbon dioxide. So the rising bubbles, since the gases rises through to reach the gas collection chamber, they will actually allow the whole water to mix together or the sludge to mix. So we do not require any kind of mechanical assistance because or mechanical parts, it will happen on its own. When it reaches at the top, these sloped walls will actually deflect the material that reaches at the top. So these sloped walls will not allow the sludge to reach to the top. Only gas and water will be there. So gas will be taken out through this gas collection chamber, and water is taken out through this outlet, and the solids are allowed to settle in this particular chamber itself at the bottom. Okay, so this actually serves as a clarifier also. Now, after several weeks of use, the larger granules that are produced, that are there in the sludge, will actually act as a filter. So the smaller particles that comes through the inlet will get settled here itself. So this is what happens in a UASB reactor. The advantage of using a UASB is that we can have high reduction of BOD since most of the particles are getting decomposed. The BOD level will get reduced, and it can actually withstand high organic and hydraulic loading rates. And as explained earlier, the sludge production is very less, so we do not require the frequent desludging. Desludging is required when this will get filled. But since the amount of sludge that is produced is very less, the desludging frequency is very less. And the biogas that is produced can be used for energy, but we may have to do some pre-treatment so that we can remove the, water molecules that is present in the biogas. The disadvantage of this is basically the treatment may be unstable with variable hydraulic and organic loads. Okay, so it would be better to make sure that there is no huge fluctuations that happens. Then this, as we said earlier, this requires the operation and maintenance by a skilled personnel, and it is actually difficult to maintain proper hydraulic conditions. We have to ensure that the upflow that is coming and the settling rates, these needs to be balanced. Then at full capacity, the USB reactor will take a lot of startup time. And we may require a constant source of electricity for the allowing the water to enter the reactor. It needs to be pumped in because the water has to be upflow, right? Then not all parts and materials may be locally available, so that can be an issue. Then the design and construction of this also requires expert opinion. The effluent that is coming out as well as the sludge that is coming out of the reactor will require proper treatment is done so that we can convert the sludge that is produced into a good fertilizer, and we may have to again treat the effluent because it may contain some microorganisms or salt. So compared to anaerobic process, this doesn't have good efficiency. So if you look at the applicability of a USB reactor, this is not appropriate for small or rural communities without a constant water supply or electricity. Constant supply of water is required here. And even though this technology is very simple, relatively simple to design and build, but developing the granulated sludge may take several months. So that is why it is said that long startup time is required. Now the USB reactor has the potential to produce higher quality effluent than septic tanks, and they can actually do so in a smaller reactor volume. So compared to septic tank, the same amount can be digested in a USB reactor with a smaller volume, but this is mainly used for large-scale industrial wastewater treatment. USB system is mainly used for large-scale industrial wastewater treatment with high organic loading, and its application to domestic sewage is actually relatively new. It is only being used very recent. And so this is mainly used in industrial plants such as brewery or distillery or food processing or pulp and paper waste, etc. Because these uh, typically the process removes 80 to 90% of the COD. And when this influent is of low strength or when it contains too many solids, proteins or fats, the reactor may not work properly. The temperature is also a very key factor affecting the performance of this. So that is all about a USB reactor. I hope you understood the concept. Thank you.